In brief, at 7:17 a.m. on the morning of June 30, 1908, a mysterious explosion occurred in the skies over Siberia. It was caused by the impact and breakup of a large meteorite at an altitude roughly 6 kilometers in the atmosphere. Realistic pictures of the event are unavailable. However, Russian scientists collected eyewitness accounts of the event. I believe that we now know enough about large impacts to decode the subjective descriptions of the witnesses and create realistic views of this historic asteroid impact as seen from different distances. What do we know about the explosion? You can get a sense of the magnitude of this event by comparing observations made at different distances. Seismic vibrations were recorded by sensitive instruments as much as 1,000 kilometers (600 mi) away. At 500 kilometers (300 mi), observers reported deafening bangs and a fiery cloud on the horizon. About 170 kilometers (110 mi) from the explosion, the object was seen in the cloudless daytime sky as a brilliant sun-like fireball. Thunderous noises were heard. At distances around 60 kilometers, people were thrown to the ground or even knocked unconscious, windows were broken, and crockery knocked off shelves. Probably the closest observers were some reindeer herders asleep in their tents in several camps about 30 kilometers (20 mi) from the site. They were blown into the air and knocked unconscious. One man was blown into a tree and later died. Everything around was shrouded in smoke and fog from the burning fallen trees. My paintings of the event a few years ago, I decided to use eyewitness reports such as the following ones, collected by Russian scientists decades ago, to reconstruct the appearance of the event from various locations and at various moments. Here are descriptions of my work so far. Witnesses in the town of Kirinsk and nearby towns at the same distance recollected the fireball flashing across the sky in the following terms. A ball of fire coming down obliquely. A few minutes later we heard separate deafening crash-like peals of thunder followed by 8 loud bangs like gunshots. A ball of fire appeared in the sky as it approached the ground, it took on a flattened shape, a flying star with a fiery tail, its tail disappeared into the air. After this object passed across the sky, it approached the horizon where it was consistently described from this distance of 400 kilometers as appearing like a pillar of fire, then replaced by a cloud of smoke rising from the ground, or a cloud of ash on the horizon, or a huge cloud of black smoke. From a closer distance of around 200 kilometers, several witnesses gave a better description of the object itself. It was called diffuse bright ball 2 or 3 times larger than the sun, but not as bright. The trail was a fiery white band. Inconsistent colors were mentioned. White, red, flame-like, bluish-white. Perhaps it had a flame-like iridescence. I used these descriptions in this painting, but I compensated. A second witness said, "I saw the sky in the north open to the ground and fire poured out. The fire was brighter than the sun. We were terrified, but the sky closed again and immediately afterward, bangs like gunshots were heard. We thought stones were falling. I ran with my head down and covered because I was afraid stones may fall on it." In this painting I tried to show the moment when the sky opened and with fire. I used the more distant reports of the fireball spreading and flattening at the end of its trajectory to give the shape of fiery trail in the explosive fireball. I painted the basic landscape from life in a Siberian-looking landscape outside of Flagstaff, Arizona, basing the structures on old photos from the expeditions to the Siberian impact area. Because the object exploded up in the atmosphere, instead of hitting the ground, it left no crater. The effect on the ground was limited to devastation of a large forest area. At ground zero, tree branches were stripped, leaving trunks standing up. But at distances from roughly 3 out to 10 miles, the trees were blown over, lying with tops pointed away from the blast. No one was known to have been this close to the blast. The closest humans were probably herders camped in tents roughly 30 kilometers from ground zero. They related. Early in the morning when everyone was asleep in the tent, it was blown up in the air along with its occupants. Some lost consciousness. When they regained consciousness, they heard a great deal of noise and saw the forest burning around them, much of it devastated. The ground shook and incredibly prolonged roaring was heard. Everything round about was shrouded in smoke and fog from burning, falling trees. Eventually the noise died away and the wind dropped, but the forest went on burning. Many reindeer rushed away and were lost. One older man at about this distance was reportedly blown about 40 feet into a tree, causing a compound fracture of his arm, and he soon died. Hundreds of the herders' reindeer, in the general area around ground zero, were killed. Many campsites and storage huts scattered in the area were destroyed. During a workshop of the International Association for the Astronomical Arts, I painted this view at Mount St. Helens, Washington, where the devastated area bears an uncanny resemblance to the photos of the explosion site. At both the Siberian site and Mount St. Helens are vistas where one sees nothing but felled trees, mile after mile, across distant hillsides. The transient heat flash from the fireball was felt by the witnesses at Vanavara, and apparently within about 30 kilometers, it was strong enough to ignite small temporary fires in the forest and singe tree bark. I based the view of the cloud in the sky on the distant reports of a ashy-colored cloud of smoke forming at the site of the blast. It was probably augmented some minutes later by smoke from the burning forest. What was the explosion? Because the meteorite did not strike the ground or make a crater, early researchers thought the object might be a weak icy fragment of a comet, which vaporized explosively in the air and left no residue on the ground. However, modern planetary scientists have much better tools for understanding meteorite explosion in the atmosphere. As a meteorite slams into the atmosphere at speeds around 12 to 20 km/s or more, it experiences a strong mechanical shock, like a diver belly flopping into water. This can break apart stones of a certain size range, which explode instead of hitting the ground. Some of them drop brick-sized fragments on the ground, but others, such as the one that hit Siberia, may produce primarily a fireball and cloud of fine dust and tiny fragments. In 1993, researchers Chris Chiba, Paul Thomas, and Kevin Zonley studied the Siberian explosion and concluded it was of this type, a stone meteorite that exploded in the atmosphere. This conclusion was supported when Russian researchers found tiny stony particles embedded in the trees at the collision site, matching the composition of common stone meteorites. The original asteroid fragment may have been roughly 50 to 60 meters, 50 to 60 yards, in diameter. If asteroids hit Earth, why don't we see more such explosions? Many asteroidal fragments circle the Sun. The Siberian object was merely the largest to hit the Earth in the last century or so. Had it hit a populated area, devastation would have been enormous. If there are many asteroid fragments, why don't we see more hits? We do. The problem is that they have not been understood until recently. Current studies reveal that such explosions may happen every couple of centuries, however, 6 out of 7 happen over the ocean, and few happen over populated land. A key to the phenomenon is the larger the impact, the rarer it is. An Air Force satellite in the 1990s detected a smaller explosion over the Pacific. In 1972, a 1,000-ton object skimmed tangentially through Earth's atmosphere over the Grand Tetons in Wyoming and then skipped back out into space, like a stone skipping off water. It was photographed by tourists and detected by Air Force satellites. Had it continued on into the atmosphere, it could have caused a Hiroshima-scale explosion over Canada, somewhat smaller than the Siberian blast. Even larger objects have hit Earth, but they are more rare. For example, an iron asteroid fragment perhaps 100 meters across hit Arizona about 20,000 years ago, leaving the kilometer-wide Arizona meteor crater, which is open to visitors, and a 10-kilometer asteroid hit Earth 65 million years ago, ending the reign of dinosaurs. Brick-sized interplanetary stones fall from the sky in various locations every year. Several houses and a car have been hit in recent decades. Tiny dust grains are even more common. They can be seen every night if you watch long enough. They are the bright streaks of light sometimes called shooting stars. Interplanetary space contains many small bodies of different sizes. All of them move in elliptical orbits around the Sun as prescribed by Kepler. Occasionally their orbits intersect those of planets, leading to a collision. Large enough bodies leave sizable craters on planets or satellites. Answer: let's make use of what scientists call an order of magnitude estimate, or back-of-the-envelope calculation. If we imagine spectacular catastrophic explosions larger than Tunguska happening every 300 years and having effects visible over 100 kilometers or more from ground zero, then there would be one over land about every 1800 years and perhaps one over a populated area every 3600 years or so. Thus it seems plausible that in 12,000 years of oral tradition and about 4,000 years of written records in some cultures, there may have been one or more explosions considerably larger than the Tunguska event. By the same logic, if Tunguska-scale events happen once per century, there could have been several just in the last several scattered around the populated land areas of the world in the last 3,600 years. Thus, it seems at least plausible that large explosions of meteoritic objects were among the celestial events, together with smaller meteorite impacts, auroras, hurricanes, storms, and floods, that gave rise to belief in capricious godlike forces acting from the skies. problem. Recent scientific studies by meteorite researcher Christopher Chiba have estimated that the Tunguska event may have been caused by the explosion of a stony meteoroid about 30 meters in diameter, traveling at about 15 kilometers per second. Compare the energy released by such an object with that of an atomic bomb such as those dropped on Japan in World War II. Answer. Here again we can make a simple order of magnitude calculation. First, we have to know the energy liberated by an A-bomb. The Hiroshima bomb expended the energy of roughly 10,000 tons of TNT, or 18 kilotons in military parlance. 1 kiloton, 1 KT, is about 4.2 x 1012 joules. The joule is the unit of energy in the Standard International, or SI, set of scientific units. The Hiroshima bomb thus represented roughly 8 x 1013 joules of energy. Now all we have to do is calculate the energy of the meteoroid. In freshman physics courses, you learn that the kinetic energy of a moving object is 12 mv2. The trick in using any equation like this is to be sure to use the correct units. In SI, the units are meters, kilograms, and seconds, so that mass m must be in kilograms and velocity v must be in meters per second. Thus, right away we can say that v in the equation will be v equals 15 kilometers per second or 1.5 x 104 meters per second. To get the mass, we have to figure out the mass of a 30-meter wide rock. Rock has a density of about 3,000 kilograms per cubic meter,